Hi, this is the Wireless LAN lab with Huawei technology. In this lab, we're testing a special mode called, from the wireless point of view, we're testing the direct mode and tunnel mode at the same time. So this is why we call this lab a hybrid mode. Hybrid wireless LAN mode, because some VLANs are used in a direct mode and other VLAN are used in a tunnel mode. In this topology, we have a corporate environment where we have a central site. In this central site, it's like a company network, obviously. In this central site, we have a border corporate router, and it's like a central router. This router is performing as a border router for the WAN connection. In this case, we are supposing a WAN service provider in this switch. This switch is acting like the WAN network. This one in reality could be a MPLS service, MPLS VPN. Okay. Below the border corporate router, we have a switch core. This switch core is performing the VLAN inter-VLAN routing. So all VLANs are finishing here. All VLANs here in this central site. Okay, so which VLANs do we have? Well, we have, for example, VLAN 100, VLAN 110. We have VLAN 101, 102, 103, VLAN 200. These VLANs are VLAN that are in this central site. So hanging down from this switch core, we have these access switches 1 and access switch 1 and access switch 2, and hanging down from this access switch we have the access points, the wireless access points. Okay, in this case the connection between the access point and the switch is with two links, but it is just for showing the wire port profile feature. It's a feature used to when we need redundancy, link redundancy between the access point and the switch. So we have to do a link aggregation in between those devices. Connecting to the switch core is these access switches and the access controller. Okay, so in this lab we call mode layer 3. Why we call layer 3 this lab? Because access points they connect to the access controller, they register to the access controller, but the VLAN for registering, also called the access point management VLAN, the VLAN for registering access points on the controller, it takes two steps, because in this step is VLAN 100, and this switch core changes that VLAN to 110. So the access points and the controller are not in the same VLAN. Access points are in VLAN 100, and the controller, which is in another place of the network, in this case is on VLAN 110. So one device, in this case the switch core, has to route the registering process between the access points on VLAN 10 to VLAN 110, where is the access controller. So this routing between these two VLANs is performed by the switch core. So in other scenarios, simpler scenarios, we could find the access points and the access controller on the same VLAN. This is called a layer 2 mode. But in this case, we call layer 3 mode because access points and controller are on different VLAN. So some device has to route all the traffic, all the traffic between the management traffic from the access points, which is called the CAPWAP traffic, CAPWAP capabilities and provisioning of wireless access points. All the CAPWAP traffic has to be routed from the VLAN 100 to VLAN 110. So that's why it's a routed or layer 3 mode. Okay. So in this scenario, at the main site, we have the VLAN 10. VLAN 10 is just for connecting the switch core to the border router. It's just a VLAN for connecting to these two devices. Also, we have a VLAN 200. This VLAN 200 is just for connecting the switch core and the access controller when the access controller has to going out to the one service provider, to the wide area network. When the access controller has to go out, it uses the VLAN 200. Okay. And as I told you before, we have here the VLAN 100. Okay, for this from this switch core to the access points, and then we have also VLAN 101 or 101. This VLAN is for corporate wireless LAN service, or SSID wireless LAN corporativa or corporate. Okay, and also we have VLAN 102 and VLAN 103. Then VLAN 102 and VLAN 103 are for the SSID VLAN invited or invitados, invited people. Okay, so for SSID corporate, we have VLAN 101 corporate wireless LAN users, and for invited SSID invited, we have VLANs 102 and 103. So these two VLANs are mapped to the same SSID, invited wireless LAN. Okay. Then we have the connection to the one service provider. Then we have another site, Lautaro plant. Plant is a name here, and Lautaro is a city of Chile, a city in the south of Chile. So we imagine we have here a plant for this company, and in this site, in this branch, we have another access point. This is the access point 3. So this access point has to be managed. So he has to have a VLAN for management, and this VLAN for management is also called VLAN 100. But this VLAN 100, it's not the same as VLAN 100 here, because these are different routed domains. So what we call VLAN 100 here, it's that network 10 100 100 0/24, and what we call VLAN 100 here is network 10 101 100 0/24. So obviously, because these are different routed domains, so as they are different routing domains, we can call the VLANs. The VLANs are locally significant. So VLAN 100 here is just at this site, and VLAN 100 here is for this site. So why we name it 100 in both sides? Well, because for simplicity and for policy, for corporate policy, because we could say I need that all VLAN that are used for access point management are VLAN 100 at all sites. So instead of complicating things and thinking that in each site I need a VLAN for management 100, at another site VLAN for AP management 101, 102, and so on. It could be very difficult to manage. So it is simpler to think that at all sites just VLAN 100 is used for AP management. So this is a VLAN 100 and then the same, but these are different VLAN 100s. Okay. For corporate users and invited users, the same. We have the same SSIDs, corporate, invited, here corporate, invited. But for invited, also we have VLANs 102 and VLAN 103. Okay, but at this for invited users, it's a little different, because here we have this table, corporate wireless LAN or SSID for corporate users. We are using it in direct mode. So when we use it in direct mode, we have to provide connectivity from the local device. So that's why we have here VLAN 100 and VLAN 100. VLAN 101 and VLAN 102, because VLAN 101 and VLAN 101 at these sites. These VLANs are for users in the corporate VLAN, okay, corporate wireless LAN. But these VLAN are in direct mode, are controlled, and the traffic is managed by the local device. But for VLANs invited, or users in the wireless LAN, in the invited wireless LAN, that kind of SSID service, wireless LAN service, we are using them in tunnel mode. So what does it mean, tunnel mode? Well, tunnel mode is means that the traffic from this wireless LAN service SSID is managed by the access controller, not by the local device. Is managed by the access controller. So the traffic for the invited wireless LAN service has to finish here at the access controller. It is tunneled by the control VLAN. In this case, VLAN 100 and then 110 is tunneled the traffic from the VLANs 102 and 103. The VLAN, the AP management VLAN, tunneled the VLANs for the service set for the invited at this side. So here at the another side, the same. The VLAN for the AP management, which is the 100 here, 100 VLAN, has to tunneled the traffic for the invited in order to be routed for the access controller, because it's a tunnel mode. So this traffic has to be tunneled to the access controller. So because this VLANs has to reach this access controller, and the VLANs for the invited here the same, so all of them are hanging from the same device, in this case the access controller. So all of them are in the same IP network. So VLANs 102, 103, and 102 and 103 from here are all these VLANs 10, 100, 102, 10, 100, 103. Why is this? Because all of them are hanging from the same device, which is the access controller device. Okay, and then the access controller de-encapsulates all these channels and passes to the switch core, and the switch core route this traffic to the rest of the network or for the WAN service provider. So that is the difference between the wireless LAN service managed in a direct mode and the wireless LAN service managed in a tunnel mode. Okay, so at this point we're going to check some configurations at the devices of this topology. Okay, well, we have the switch for access 1, so we can be here and show the configuration. Excuse me, display current configuration. Okay, so at this point we're going to analyze the configuration. So this switch, access switch, is managing the VLAN for the access point, so which is the VLAN 100, and it has to manage also VLAN for the corporate users. And remember that corporate users are in direct mode, so it is not tunneled. This is the 101. Okay, so at this point we created some VLANs at this switch. For example, 100, 102. 102 would be unnecessary, and no, it's not needed, but we were using 100 and 101. So we're going to display all the configuration here because it is a switch that are using a link aggregation group. So we had to create a Ethernet trunk, which is like a port channel or ether channel, either channel if you know the Cisco terminology. So here we see a ether trunk, and the ether trunk is passing VLANs 100 to 101. 100 is for AP management, and 101 is for the wireless LAN corporate users, which is passing in direct mode. Okay, we have to put a special command here to in order to disable sending spanning tree BPDU frames, because this link aggregation group is forming just one logical link. So when we created the service, we verified that we have some alerts from spanning tree. So we enabled the BPDU filter, and the alerts went away. So no problem with these alerts. Port isolate enable group 1 is just a command. It's not really a must. It's not a must here in this configuration. It's a well, this command is a, for example, if you have another ports in the same switch, another ports on VLAN 100 and 101, if you don't want that broadcasts generated on in these other ports passing to this link, to this logical link, if you don't want that broadcast to pass, so put this command, port isolate enable. That's why this, because all these broadcasts who is generating in other ports are using the wireless radio resources. So could be a lot of noise in the from a radio point of view, that broadcasts. So in order for that broadcast not to pass to the wireless LAN radio environment, so put this port isolate command. Okay, so this is the Ethernet trunk, and then we will see the Gig Ethernet Gig Ethernet 101. So that is the uplink here. So it is a trunk, and we see that we are passing VLANs 100 to 101. Okay, that's all the configuration for this access switch 1. The switch access 2 is the same, exactly the same VLAN 100 and 101. The Ether trunk, and the trunk uplink. Okay, the same. So now we're going to see the switch core configuration. Okay, display current. So at this switch, we'll see all VLANs here created. VLAN 10, remember VLAN 10 is for the connection to the border corporate router. VLAN 10, VLAN 100. VLAN 100 is the AP management VLAN hanging to the access points. Then we have VLAN 101, 102. That is for the VLANs for the that VLANs 101 it's for corporate users. 102, 103 it's for the invited users. Then we have VLAN 110, which is the same as VLAN 100, but remember that VLAN 100 finishes here and then continues to the access controller as a VLAN 110. Remember that we have these two VLANs. That's why we call this lab a routed or layer 3 lab, because APs and access controllers are not on the same VLAN. Okay, so VLAN 110, and then VLAN 200, that is VLAN used for the access controller in order to go out of the network, like a special out interface. Okay, well, continue. Then we have this is it's not important for our lab, for our wireless LAN services. This access control list is just a list we use in order to VLANs invited VLANs, invited wireless LAN users to not to enter the corporate users, corporate VLANs. So it's just for the invited to go out to the internet without attempting to penetrate the corporate network. Okay, so then we will see all the interfaces, VLAN or VLANIF interfaces, in order to make the routing or inter-VLAN routing that is performed by the switch core. So we have interface VLAN 10, we have interface VLAN 100. So interface VLANIF 100 is very important because, as you remember, this VLAN is for the AP management. The access points, when they try to register on the access controller, they start performing registering messages on VLAN, in this case VLAN 100. So they try to perform a DHCP request on VLAN 100. So in this VLAN 100 we see that we have precisely a DHCP relay service. So that's why we have to forward all the DHCP requests that come from the APs So we have to forward to the access controller. So then we have a DHCP relay service. Okay, and who is offering DHCP service for the APs? Well, the access controller. The access controller, we're going to see a pool, a DHCP pool there that is performing all the necessary IP addresses leases to the access points. We can see this at this moment. For example, if we change to access controller, we will see a small part of the configuration here, when we see this IP pool, like here. So that's where we have the pool APs, gateway list, because all the APs hangs down from the, remember, VLAN 100 directly, then it's changed to VLAN 110. Remember for the topology, for simpler for visualization, we use always the third number of an IP address matches the VLAN number. So this address is from VLAN 100. The network for assignment of IPs, IP addresses to the access points. Some excluded. This is not really necessary, but we included in this lab some ranges from excluding. And one command is very important. This command, option 43 sub option 3 ASCII, and then an IP. What is that IP address? Well, this IP address is the IP that the APs, the IP is the IP address that the access points need to register for the wireless LAN service. 10, 100, 110.1. So when these access points ask for DHCP service, the DHCP request come here, discover, I'm here, the interface VLAN 100 forwards, it makes a relay, as you saw before, it makes a relay. So the relay comes here, and then the IP pool offers an IP and offers this sub-option. So this sub-option is telling the access point you have to register your wireless LAN service on this IP. This is your controller. This IP address is the way that we tell the access point that is your access controller. So then the access point obtains an IP address and then register to that IP. Okay, so it's very important is this configuration here. Come back to the switch core. So for the other VLANs, for example, the corporate is managed directly from this interface VLAN 101. So we can see that the DHCP server is configured directly here. Some range excluded, the DNS, etc. But because all users in the corporate wireless LAN service are hanging from here, from this interface. So this interface is going to offers the DHCP service to the wireless LAN users. Then we have 102, 103 that are used. These interfaces, remember, are used for the invited users. Then we have the VLAN 110, that is the other VLAN used for AP management, in this case the connection for the access controller, and then the VLAN 200 that is used as the exit for the access controller to go out of the network. Then we have the configuration of layer 2 ports. Layer 2 ports, just hybrid ports, could be trunks or could be hybrid, the same, because we need to pass all that VLANs in a tagged way, okay, in a tagged way. So that's why we need all these ports with a tagged specifying which VLANs need to be tagged. In this case, for port 101, in this case 1 Gig Ethernet 001, 100 to 101. Remember that in this zone we have just two VLANs, 100 for AP management and 101, which is the corporate users. The Gigabit in Gig Ethernet 002, the same, VLAN 100 to 101. Gig Ethernet 003, which is this port, it's very important because the VLAN 10, the way out of the switch, connection to the border corporate router. And then we have this port, which is a VLAN 20, excuse me, a Gig Ethernet 0020. So 20, we have all the VLANs needed to pass that link. 102, 101, excuse me, 101, 102, 103, 110, 200. All VLANs that need to be passed that link. Then we have a routing protocol, because some kind of traffic has to be routed between switch core and access controller. So we need a routing protocol here. We're using OSPF. And then we have a traffic filter, which is an access control list that show you before. A special access control list that we needed to filter the traffic from invited users for not reaching the corporate network. So we assigned this access control list to the VLANs 102 and 103 in an inbound way, because that's that's needed to limit the traffic from users in VLANs 102 to 103 to try to reach the corporate network. So that's all the switch core. Okay, so then we have, well, corporate route. Corporate route is just routing, just not so important. It's just routing. So we have here some interface with an IP address. Okay, the LAN interface, local area network interface, and then we have the Gig Ethernet 001, which is the WAN interface. Okay, and then we have a routing protocol, in this case OSPF. So that's nothing more is needed in border corporate router. One is service provider, the same, just two interfaces. This switch is not running OSPF. Excuse me, yes, it's running OSPF because it's one service. It's emulating MPLS. Okay. Then we have the load tower plant, which is other router. We're going to see it after. Then we have the access controller. The access controller, we're going to see the configuration for access controller. Well, we have to create VLANs, all VLANs necessary. Okay, and then we see here a special configuration called a VLAN pool. We have to create a VLAN pool, which is a assignment for a group of VLANs. In this VLAN pool, we grouped, for example, VLAN 102 and VLAN 103. Why we need to group these VLANs? Because for us, invited users, users who is going to use the SSID invited wireless LAN, these users could be from VLAN 2, excuse me, could be from VLAN 102 and VLAN 103. So at some point of the configuration, we're going to map we're going to map 102 VLAN and 103 all in a special bigger VLAN, if we could call it that way, a bigger VLAN. So that bigger VLAN is a VLAN pool. This VLAN pool, we call it pool VLAN invited, or invitados in Spanish, invited VLAN pool. So when we create the wireless LAN service for the invited wireless LAN users, we are going to assign not VLAN 102 and VLAN 103. We're going to assign the VLAN pool. So that's why we need to create this VLAN pool previously. Okay. Then it is all by default. Nothing here. Then we have the pool we showed you before for assignment of IP addresses to the access points. Okay. Then we have the interfaces VLAN if necessary to route traffic for this access controller. Okay, these access controllers needs take care of this, because we'll see just VLAN if 102, VLAN if in this case 102. It's one of the VLAN of the the invited interface VLAN if 110, which is the important interface, because that's when all the IP management traffic come here. Interface VLAN 200. Okay. Then we have, this is very important, the interface Ethertrunk 0. Why we create an Ethernet trunk 0 here? Because this access controller has not link aggregation group here, just one interface. Well, because when APs register on the access controller, they download all the configuration needed. So they need to download a configuration needed to configure these ports, this link aggregation group. So this link aggregation group configuration has to be created here at the access controller. So that's why we said Ethertrunk for wire port profile. Okay, so these are configuration needed for the Ethertrunk. Then we have the physical ports. The physical port, there is one physical port used at the access controller, and then we will see the wireless LAN service, all the wireless LAN service here at the access controller. Some kind of static routes, not important, and the wireless LAN service. Okay, wireless LAN service. Here is the important configuration. We have to create the security profiles. These security profiles for all the profiling for the wireless LAN. There are default profiles for all types. For all types of profile, we have default profiles, but we created we created special profiles for all the things we have to configure. So this security profile, security profile 1, is for assigning a password for the users of the corporate network. It's just to create a password. And this security profile, profile security 2, is for create a password for the invited users. Just that security profiles are created in order to create the passwords. Okay. Then we have the SSID profile. So we have a SSID profile, SSID1. So this SSID1, which is called Wireless LAN Corporate. So users, when they scan the wireless LAN networks, they will see Wireless LAN Corporate. Then there is another SSID profile, SSID profile 2, which is called Invited. Okay, so users, when users scan the network, they will see a wireless LAN called Wireless LAN Corporate and another called Wireless LAN Invited. Okay, these are which are called SSID profiles. Okay, then we have to create a VAP profile or virtual access point profile. So we created two VAP profiles. One is for the corporate users, or yes, corporate users. So these are VAP profile 1. So check here, let's check here. We have to assign VLAN 101, which is the VLAN for corporate users, to the SSID 1. So when corporate users are treated as VLAN 101. That's then you tied all the service at this point. Service SSID 1 is for users 101, and then with this password, security profile 1. Then you have another VAP profile 2. For a VAP profile, the by default mode is direct. So that's why in this VAP profile 1 we can see a forward mode command, because here by default is forward mode direct. But for VAP 2 we have to specify forward mode tunnel. So why? Because this VAP profile is for the invited. So which VLANs are for invited? VLAN 102 and 103, but we have to specify the VLAN pool created before. So VLAN pool invited here, and which SSID? Okay, SSID 2. And which password? Passwords security profile 2. Okay, and a special command for a traffic profile we have to create before a traffic profile. Why traffic profile? Because we were asked that users invited VLAN, invited wireless LAN service could not reach each other, could not ping each other. Okay, so we have to create the very first profile we created was the, excuse me, I'm going to see all wireless LAN again, display this. So you could see that we created a traffic profile, just one profile for traffic. We put user isolate all. So this traffic profile, where is assigned? Well, it is assigned to the VAP2 profile. VAP2 here. Traffic profile 1. This is used for this VAP, for these users in the invited wireless LAN service. They are not going to reach each other. They will not be able to reach each other. Okay. So then another configurations for the wireless LAN service, just the appropriate name of the regulatory domain, that is always needed. This is not important, just by default, all these commands by default. Here is the wire port profile. Wire port profile we created. It's just a name for this wire port profile, and then we assign a wire port, the wire port profile, we assign the ETH-trunk 0, which is as I explained it before, it is for the configuration of this link aggregation group. Okay. Then we have to create the access point groups, because all the access points we can group together with same configurations. So for the we created two AP groups. One AP group is for the access point in the central site, and the other group is for the access point at the branch site. So this first group we call Enterprise or Enterprise Wireless Access Point Group 1. So in this group we assign the wire port profile. Here we assign the profile to Giga Ethernet 0 and 1. Which Giga Ethernet 0 and 1? Well, these ports are these ports, 0 and 1. So at these ports we assign it a wire port profile, and that's why that's the way the access points know that those ports has to be grouped for a special for creating a link aggregation group. So we assign the regulatory domain to this group of access points, and then we assign radio 0, which is the 2.4 gigahertz frequency. We assign the above profile 1 and above profile 2. Okay, so what are you seeing here? What are we saying here? Well, we are saying that for radio 0, I mean 2.4 gigahertz, so we are assigning the corporate wireless LAN service and invited wireless LAN service. These 1 and 2 numbers are just the, as a number 1 assign this profile BAP 1, as a number 2 assign this profile BAP 2. Okay, and for radio 1, which is the 5 gigahertz radio chain, the radio 1 gigahertz, the same BAPs. So what are we saying with this? Well, that at 2.4 gigahertz and 5 gigahertz, the user is going to find the same wireless LAN services. Corporate users SSID and invited users SSID at both frequencies. Okay, radio 0, radio 1, and then this is a wireless LAN group 1, and then we created a wireless LAN group 2. Remember that this group is for the access point in this other site. So group 2, we have to create a different group because at this group there's no wire port profile configuration, so we cannot assign this group to the access point at the branch, because in this access point there is no wire port profile. So we have to create another wireless LAN group, regulatory domain, and then the services, the wireless LAN services, the same. So then we created the access point groups, and then we have to create the access points itself. So this access point, this MAC address, remember that the MAC address we obtain it from here. Yes, from here, the access point, we have a config, and then we have the MAC address of the access point. So when we have the MAC address of the access point, we paste it here. So the system, when the access point register the access controller, if it has that configuration if it has that configuration for the access point is going to register successfully. Okay, so we put a name for the access point name AP hole principal, the principal hole, AP hole people. So here AP hole people, that's why the access point obtains the name, of course, from the configuration. AP group, which is the group the group that access point belongs, and then some layer 1 or RF configurations. Radio 0, I want to work in channel 1. radio 1, I need to work in channel 149. Then AP1 is that. This is AP0 from the configuration of access controller. AP0, AP1. So AP1, the other MAC address, a name, okay, in the group. So, and then which channel I have to configure, because here I want to channel 6, and radio 1 I want channel 149. Take care, channel 1, channel 6 at the 2.4 gigahertz, because as the areas are overlapping, I have to configure channels that are not overlapping. In 5 gigahertz radio frequency, there's no problem because all the channels are non-overlapping. So that's why I have to I could use the same channel here and here, because the channels not the same channel not it's not relevant for the configuration here. Okay. Then we have the AP2, and the AP2, which is this access point. Okay. The name and the group. That's why the most important, the group. Okay. And then the radio, which channel, and which channel for 2.4 gigahertz, and which channel I want for 5 gigahertz. And then it's all. That's all for the configuration of the access controller. Okay. So here at Lautaro plant, in this current, you will see just the interfaces. 100 in order to manage the IP management. This is the interface for AP management. So as the access point is going to send broadcast, that broadcast has to be managed locally here. So that's why we include a DHCP server here, and the option 43 sub option 3, in order to be registered, in order to tell the access point to register here. He has to register here. That's why we include this command. Okay. Then the VLAN if interface 101, that is for corporate users. Then the interface for layer 2 port of the router, and then the OSPF routing protocol, and nothing more. Okay, so that's all the laboratory stations. The stations could see the wireless LAN corporate invited for the 2.4 gigahertz band, and wireless corporate and invited for the 5 gigahertz band. Here the same, and here the same. Okay, invited and corporate. Remember that when we, in this case, for example, that that station is connected to wireless LAN corporate VLAN. The same name, okay, the same name here and here, wireless LAN corporate, but in this case is VLAN 100, and in this case VLAN 100, but this has this IP address, 100 IP address, but at plant Lautaro this is another IP address, because remember, the VLAN could be the same name, but they are different IP networks. Okay, so this station is connected to corporate, and corporate it has this 100, 101, 101 because it's corporate, but 10, 100. And here, if it's connected to corporate, and in corporate, we have 10, 101. Yes, it's another IP network. It's the same wireless LAN service, but it's another network, 10.101, and here 10.100. Yes, because here is hanging from this, from at corporate, it's hanging from this this IP network, and the remote side is hanging from this network. Okay. And when users enter the invited wireless LAN service, some users enters VLAN 102 and another users entered 103 in a like a round robin way. When we control that round robin way at this point, when we configure the VLAN pool, here assignment even that's assignments. That assignment mode is for when the access point receives an assignment from VLAN invited users, VLAN 102. Another requirement for invited, VLAN 103. Another VLAN 102, VLAN 103. That's the way. That's what they call as even assignment mode for the VLAN pool. Okay, so that's all with the configuration of this lab. I hope you could take profit of this explanation. You could understand this explanation, and I will send all the topo of the topo file and all the configurations for the devices for you to analyze. Okay, I hope this has been useful for you, and thank you.